What if our most advanced AI tools are actually suffering from a massive creative block? The researchers behind this paper argue that large language models are trapped in an artificial hive mind, churning out repetitive, safe, and uninspired content. This presentation explores divergent-convergent thinking in large language models for creative problem generation. One part of growth. Large language models tend to suffer from a lack of novelty, often referred to as the artificial hive mind. This results in functional fixedness, where the model only views concepts in traditional ways, and premature convergence, where it rushes to a safe, average answer to satisfy prompts immediately. This issue is particularly problematic in education, where variety is crucial for engagement. If an automated system generates practice problems that are all fundamentally the same, students lose out on the diversity of thought required for true learning. The goal is to generate high-quality, distinct content, at scale, without hitting a wall of repetition. To address this, the authors revisited classical psychological frameworks, like Wallace's theory of creativity, and Guilford's structure of intellect. The core insight distinguishes between divergent thinking, brainstorming wild, unconventional ideas, and convergent thinking, which refines those ideas to meet specific rules and constraints. The researchers propose a method called CreativeDC, which enforces a strict two-phase prompting strategy. First, the model creates a divergent list of thematic scenarios while explicitly ignoring technical constraints, preventing early rejection of good ideas. Then, in the convergent phase, it selects one quirky idea and figures out how to make it work technically. Standard approaches ask the model to satisfy creative and technical requirements simultaneously, which typically forces it to converge on the safest, most average answer. CreativeDC decouples these steps, allowing the model to find a unique creative seed first, and only then applying the necessary logic to ensure the problem is solvable. Let's examine how this theoretical separation of thinking stages performs in practice. This figure tracks the Venn score, a metric representing the effective number of distinct problems generated. As the number of requested problems increases, standard methods plateau quickly, repeating themselves, while the CreativeDC approach continues to deliver a significantly higher volume of unique, distinct content. The quantitative results are striking, with CreativeDC achieving up to 72% higher diversity scores than standard chain of thought prompting. The generated problems were also over 63% more semantically novel, proving that you can increase creativity without sacrificing the utility or correctness of the material. While promising, the study implies some limitations. Specifically, the experiments focused solely on generating Python programming problems. Additionally, the tests relied on a specific high-end model, meaning further work is needed to see if these gains generalize to other domains or smaller models. This work matters because it provides a blueprint for generating high-quality educational content at a scale that human instructors cannot match. By mimicking the cognitive stages of human creativity, we can prevent AI from burning out and reverting to repetitive patterns. To learn more, head to emergentmind.com.